Coming up on this edition of the FRC Open Alliance Show, 9642 INT Robotics. Well, they were on the FTC Open Alliance. They're also here for FRC as well, giving some of their updates on what they've been doing for the REEFSCAPE game. This team definitely, you would never assume this is a second-year team. They are so well put together, and it's going to be really cool to dive into what they're doing. Of course, we're talking about what they're doing on their robots so far, an update on their chassis. They have a lot of great stuff in CAD we'll be diving into, so keep an eye out for that. And some good concepts on what they're looking at doing for their climber, where they're getting inspiration from. We talk about their ideas for a neural network and custom vision setups that they're doing as well, too. It's a lot of great stuff coming from I.N.T Robotics out of New York. Let's learn more about their progress coming up here on the FRC Open Alliance Show. Let's welcome into the FRC Open Alliance Show. You might have seen them on the FTC Open Alliance Show, but they're back here for this as well, too. 9642 I.N.T Robotics coming in from New York. Awesome team that I can't wait to learn more about their progress. They compete weeks 2 and 6 as well, too. So, guys, I know a couple of you were on FTC Open Alliance Show. Welcome back. Why don't you reintroduce yourselves? Let us know what you do on the team, and we're going to hop right into everything we have to cover for your team today.
Sure. My name is Andrew. I'm the co-captain of I.N.T Robotics, and I cover CAD and mechanical.
I'm the other co-captain of I.N.T. I cover programming, machining, and electrical. My name is Darius.
I'm the design and mechanical lead for I.N.T Robotics, and my name is Eric.
So starting off, we just want to go back to day one pretty much. So once we saw the game, we immediately started creating a chassis. So we started with a 27 by 27 chassis. We got Versa on the CNC as quick as we could. And then we have a full test chassis, which we have video of that you could put up. So this is actually new swerve modules that we have. They're a lot faster than their old ones, and they're brand new instead of being used for multiple years. So it's great to drive with a new chassis. And this allowed our programmer to get some testing early on in the season.
Yeah, so actually just going more in depth into the chassis because they're new, like not just for us, but also across FRC. These are the West Coast products, X2 inverted. We're specifically using X3 gear ratio. I believe we have the fastest gear ratio, but right now we have we've geared them to the second fastest gear ratio just because we want to see what it's all about. And as the video shows, it's pretty damn powerful. And this is right now is without Phoenix Pro. So right now we're controlling our motors without field oriented control. And basically what using field oriented control will allow us to do is basically a 15% bump in acceleration for a trade-off of slightly lower terminal velocity, which we actually don't mind because when we're taking like game strategy into account, specifically cycle times, this isn't a full field game like it's been in the past years where, like, for example, in Crescendo, we don't have to go from our line station all the way over to the other side to pick up from the human player station. Our human player station is just a couple of feet away from where we're going to score on the reef. So we'd actually rather have a higher acceleration because most of the time we're not going to be reaching terminal velocity, or if we do, we're not going to be sustaining it for that long.
So pretty much while Darius is working on the programming side of the robot, the rest of us split into different teams. We're working on different intake designs, different climber designs, and different versions of the chassis as well. We have 27 by 27 and 27 by 28. And while people were working on the different intake designs, we came down to a couple. And same for climber as well. We have a couple main and one that we're leaning towards. So we'll move into the elevator system as well, which Eric will talk about.
Yeah, so kind of backtracking a little bit to our chassis. So the test chassis that you saw in the video was a 27 by 27. But after further discussion with the team, we decided to actually finalize with a 28-inch by 20-inch chassis. The reason for this was we didn't really see reason to go with such a large chassis this year, as we kind of decided, there wasn't many mechanisms that we needed to kind of cram within the space we have. And 20 by 28 we found was a kind of a perfect middle ground, and the size allows us to comfortably fit all of our mechanisms as well as have ample amount of space for electronics. And I guess kind of diving deep into our individual mechanisms. Before we do that, I do want to take a second to kind of talk about our overall vision for our robot this year. So when we were thinking about game strategy, we obviously wanted to kind of take on all the tasks. And I guess our elevator was going to be like the main, system that allowed us to do all that. And so in terms of the elevator, we decided to go with the internally belt routed elevator. And there was a couple of reasons for this decision. And one of the main reasons actually was the kind of the weight of it. It's much lighter than I guess your typical chain cascading elevator that uses chain. And this is kind of significant because we realized that this year we have less weight to work with. And so kind of keeping that in mind, we're definitely more mindful with our weight. And that's one of the reasons why we chose to go with the belt elevator instead. And I guess another reason was because of its low maintenance. Once you kind of tense all the belts and kind of finalize everything, there isn't really much you have to do to kind of maintain it. It's low maintenance and allows us to kind of have an ease of mind when driving around.
Something I want to ask you guys, we were talking pre-show that you just got back from an FTC event, right? What is that like, that transition like going from FTC to FRC in terms of like, the pacing or the strategy or anything like that? Like you all do both. So what is that experience like? How does that actually feel to go through that?
So, it comes with its ups, it comes with its downs. I think we're very much more organized as opposed to how we were last year or our rookie year, because it was rookie year for our FTC teams and also for our FRC team. So that was very chaotic. We didn't get to where we are right now. We didn't like start building until like a month like into build season. So right now, I think it's good. We've managed to, like organize our times because we have members of the FRC team who are native to their own FTC teams from schools that obviously don't have FRC teams. So that's why they're competing with us in I.N.T. But we found like we have a system that works. We found out a better method, and honestly, I think it actually is more beneficial. Besides just the time constraints that we have to like give up some weekends to attend our qualifiers and other competing events for FTC, it actually helps more because the things, I guess, from programming perspective, the stuff that I've done in Vision for FTC, since I'm able to work at it from a smaller scale, it's still all the same concepts. Like everything I was talking about in the earlier segments of FTC Open Alliance is stuff that I'm going to be implementing here in FRC. And I know that also, at least from a mechanical side, Andrew contests to this, the stuff that he's designed, the stuff that he's built is also like similar to the stuff that we could be seeing in FRC, and definitely like the stuff that you could do on an FRC FTC robot will most likely be reflected on like an FRC robot that might be of a similar design.
Yeah, I can't think of a better way to really prepare for both programs, honestly, and having that experience through that. So really cool. So all right, let's continue. What else do you want to cover?
Right. So moving into our different intake designs, we came down to two main ones, and one of them it pretty much has two rollers on either side, and it's able to open and close to adapt to the game piece. And the other one is more of a static design, so pretty much it more so pinches the game piece, the algae, the larger ball, when compared to the PVC pipe, where it gets intake nice and snug, and the algae gets pinched in. So there's two different designs. They're pretty much the same type of concept. However, one of them is more adaptable to the different types of tasks to maybe put up against. I might handle the ball easier. We haven't actually tested physically, and that's what we're going to get up to in the coming weeks. But pretty much these are our different designs for in terms of CAD of our two intakes. And then if you want to move on to climb or the elevator, yeah. So this is our differential, which Eric can talk about.
Yeah, so kind of another mechanism we were playing around with was a differential claw, and I actually saw this kind of design on Instagram one day. It was a team using it, and they're using this similar to kind of I guess mechanism, and we kind of like designed like a elementary version of this. We're still yet to test it, but we have high hopes because of its kind of like it's very compact, and we're able to kind of have 2 degrees of motion. We have up and down, and we also have 360 degrees around this axis right here. Yeah, so this is our kind of master assembly slash master sketch document, and here is where we do a lot of like the planning and where we'll eventually like visualize the final assembly of the robot. And so here is that kind of our master sketch. Our original, we decided to go with the elevator in the back, and the belt elevator would go to all, I guess, 4 levels of the coral. I mean
That's a reef.
the reef, and you can kind of see that here in the master assembly. With this elevator we're able to reach all 4 levels. So we have the top level here we have that preset, and then when we need to go down, we would just simply kind of go down to the lower levels and so forth. And we also kind of decided to put the elevator in the middle. As you can see before, we kind of had the original idea of putting it in the back, but because of like possible like weight distribution issues, we'd figured that having it in the center would always kind of establish that our center of mass is always near the center and would prevent like tipping.
Yeah, and then just to specifically like reference a team we took inspiration from, because again, well, we do agree that having the elevator pivot from the back would probably make for an easier time climbing because we have more leverage. We're just trying to think of like auto and teleop period as a whole. We don't want to have any sort of tippiness because we don't want to have to slow ourselves down just because of the fact that if we move too fast while we're like even slightly extended, we'll be tipping. That's not a problem that we want to deal with. But also, we've seen two robots, at least in 2023, successfully execute like a similar concept, 1768 and 3015 Robo Rangers, I believe, where basically they had a pivoting telescoping arm in the middle of the robot. And what I really liked about this design, obviously, we're not going to be going with a telescoping arm. We're going to port it to be compatible with an elevator. But what I personally liked about this design is that another goal that we had is that we wanted ground intake. Because while we do understand that in some games, especially like 2019 or Deep Space, it might have come off as as like a red herring, but I really don't think that's the case in this game, especially because of the fact that the human player stations are not protected. So at higher levels of gameplay, especially like at worlds level, um, you're going to see people who are going to be playing some crazy defense on the human player station and want to be able to have an alternative where a human player just starts shooting out coral and they disperse in different directions. The person that's playing defense isn't going to be able to keep up with all of them. And we have the capability to, just like how 3015, all they did was pivot their elevator down. And because the intake and the cloud that we'll have will, at least, even if it's not through a differential, or at least have 1 degree of motion where it can pitch itself up and down, we'd easily be able to pick up from the floor. And that wouldn't have to be a separate mechanism or anything like that. And it's already synergizing well of our pre-existing mechanism of having a pivoting elevator.
So is that claw that you're designing, or the different options that you have, are those looking at picking up both algae and coral?
Yeah, realistically speaking, want to have something that can do algae and coral in the same string.
Gotcha. So yeah, that'll be really interesting to see. I agree with you. I think floor pickup's going to have a lot of viability in the game. You mentioned, like, especially in later levels of it. I agree. As the way the meta evolves in this game, I think floor pickup's going to be a very valuable asset for teams to have as well too. So yeah, cool price. Anything that you guys have considered in terms of climbing or anything like that yet?
Yeah, so we also have a couple of climbing ideas in mind. So one of them is actually taken inspired by like a Lego robot that we saw like very early in the build season. And that one was pretty much using sort of like a conveyor system where the actual cage lands on top of your robot and you're clasping onto it, pulling yourself up with that, which we'll pull up real quick right now. And this was something that we all saw very early on. It was like an idea that now it has evolved into many different types, where we use the same type of like wedge idea, but just now since we have the elevator, which is on a pivot, we were able to have the ability to maybe use the elevator and have a actual clamp on the elevator to pull ourselves up using that instead. So this is just a very early concept of something that we saw where we could take inspiration from. But now what we're moving towards is something which you can go to the master sketch, where we see or if you have something on the back of the elevator, that we have clamps where we can wedge and use the weight of the robot to actually passively clamp onto the cage, and then we were able to tilt ourselves using the pivot from the bottom. So that was our main climbing idea that we have for this robot, and that's something that we're gonna get working on next. Since we have the elevator assembly and we have everything else, everything just needs to be combined and put together.
And for your team, what is kind of the general time frame? Do you have certain deadlines that you're setting for your team, or is it just one of those like, hey, by the time we get to week 2, everything needs to be ready? What does that look like for I.N.T?
So for INT, obviously, I think we operate in a bit more of a unique way because we have to be very conscious of all the FRC members, which is like 70-80% of FRC members who come from an FTC team. So for them, their FTC competition doesn't end till like early March, which is the same time as our week 2 event. So we want to make sure that like our deadlines are playing nice with each other and we aren't pushing people to prioritize one team over the other. But for those of us, like for example, Eric, who are like strictly part of the FRC team, we're able to like recognize these members and allow them to have a bit more like lenient deadlines that are more oriented towards just FRC. So for example, we spent, I'd say, the first week with no like finalized prototypes. We knew that we knew that we wanted a like internally rigged continuous bow elevator, but we didn't know if we wanted to pivot, we did stationary, if we wanted to pivot from the back, middle. So for example, what he worked on wasn't necessarily the finalization of its placement on the chassis, but more so the elevator itself. So now what we have is that we can make the final decision of, no matter whether we want it to be pivoting, stationary, middle, or back, we at least have the elevator, and with like all the pulleys in place, we have all these specific things. And that was a deadline that he set for himself by the end of week 1 that he reached. And so now, as we're finishing up with week 2 and going into week 3, all the cloud designs that you saw over there, those were also week 1 to 2 deadlines that were made. And so right now we're entering into the physical phase where we already know the design or the idea that we want to have behind our robot, and it's just more so like physically assembly and making sure that all the parts work together. And that's going to be sort of like phase of week 3 to week 4ish.
Yeah, it makes sense in there. Want to ask you in regards to anything you want to talk about for, we were talking earlier about doing vision on your robot or anything from autonomous routines or anything like that. What do you want to wrap up with?
Oh yeah, so just wrapping up with sort of the software side of this, and this is what I handle. I know that like teams and like people are always saying that the more seconds you can shave off of a cycle, like the more cycles you gain at the end of the end of the match. I think this is the game that truly exemplifies this because with with a game with full field cycles, shaving off like 1 to 2 seconds off each cycle will only culminate in like 1 to 2 extra cycles at the end. But now that it's like even less than half field cycles, you really notice a difference. So as a driver, I don't want to ever like end up in the situation where during a competition, during a match, everything I'm doing is manual alignment. We want to be able to line up to the April tags, the human player station, and then from that April tag to the next April tag, at the reef, we want to have like an automated like sequence of scoring. And to that end, we want to be using like all the vision opportunities that we can use. So right now, the vision setup that I'm going for is 2 Arducams with Orange Pi co-processors, where we're planning to run photon vision on whether it be the Arducams or the Limelight. And then on the actual claw itself, we want to run a Limelight 4 with the Helio co-processor, because we want to run neural networks on the actual purple like branches of the reef itself, because we want to sort of like, you know how UPS has like this sort of like last mile policy where they'll ship a package to you in whatever methods, but then when that last mile to actually bring it to your home, they hand it off to someone who like personally knows your neighborhood the best. Want to be able to do that and want to use a neural network to know exactly the distance between, because the April tag, well, is beautiful for rotation, the translational offset, but obviously, especially if we have to be like up flush against the reef to score, we're gonna need something else that's not relying on April tags, and that's where we want to have the neural network come into play. And specifically, the reason why I want to use the Helio accelerator is because not only is it going to help with the neural network, basically think of it, if the Limelight 3 had the Google Coral, then the Limelight 4 is going to have the Helio. And we have a Halo 10H back at home that we can play around with. So we believe that by the time that the Limelight 4 and the Halos get shipped out, we already have like a lot of sufficient background knowledge to actually implement this like as fast as possible, so we can actually achieve what we're trying to do here.
Well, I can't wait to see that, especially when we have you on next. If there's any progress for that, I think that'd be a really cool thing to look at and dive a little bit deeper into as well, too. So, I.N.T Robotics, thank you so much. By the way, I know it's FTC, but congratulations on your qualifier win this past weekend on that front. We hope that translates into FRC for you as well, too, and you're off to a great start. So can't wait to see your new updates coming to your build log, so keep an eye out for that, and good luck the rest of the way. We'll see you back on here in just a couple weeks.
Thank you.
Thank you.